Here are two sequences where we have the first few terms and we're asked to find the nth term. Now, what you're really to do is to find out what is the rule, the formula that generate these terms and will generate the other terms. Alright? I took this from the textbook, Pre-Calculus, Mathematics for Calculus 7th edition. Now, given these, let's see how you could possibly argue out what these could be. Here, for part A, we have a half. First of all, terms are A1, A2, A3, A4, and so on. So we have the first, second, third, fourth, and so on. All right. In the first term, n is 1. You might say, if n is 1, could this be n over n plus 1? Because you would have 1, which is n over n plus 1, which is 1 plus 1. So it would be 1 over 1 plus 1, which would be 1 over 2. But when you look at the second term now, the second term, if you put n up here, it should be a 2 over something, but it's a 3. So this wouldn't work. So you say now, if n is 1, but here n would have been 2, how do you get, or what would you have to do to change this now? So you try something else. It's not n over n plus 1. You'd have to make some adjustment. Could this be, alright, if you say n certainly is 1, but 1 plus anything would not give you this 1. If you say n plus 1, you would get a 2 up here. So that wouldn't work. If you say it's n minus 1, you'll get a 0 up here. What could you do to make n1? Put in a different pattern and get 1 up here still. Suppose you make 2 times 1 is 2, then you minus 1 from it. Alright. Let's just concentrate on what is going to happen up top first. You're going to have something divided by, then something divided by, and it should be 3, then the other one should be 5, then the other one should be 7. Up here, up top, you have 2 times n minus 1. If n is 1, you'd have 2 times 1 minus 1. Okay, it works so far for this. This would be 1. It's 1 over something. Would it work up here? If it's 2n minus 1, this would have been 2 by 2 minus 1. 2 2 is 4 minus 1. 4 minus 1 is 3. It's 3 over something. Well, it seemed to be working. Could the third one have a 5? Let me space out these a's. I don't really need the a's. Let's erase them. I don't really need the a1, a2, and so on. Here, in second position, the numerator is 3. If you have 2 by, the second is 2. Second position, 2 times the position minus 1, 2 2 is 4 minus 1 is 3. It worked for this first and the second. What about the third? You should get a 5 up top. Alright, it's 2 times the position is 3, the third position minus 1. Remember, we're working with 2n minus 1. Here, if you say 2n minus 1, then this would be 2 by 1 minus 1, which would be 2 minus 1, which is 1. This is what we're working with for the numerator part. 2 times n minus 1. The third term is a 2 times 3 minus 1. 2 by 3 is 6. 6 minus 1 is 5. Okay, good. It seems to be working so far. The next is 7. In fourth place is 2 times 4 minus 1. 2 4 is 8. 8 minus 1 is 7. Alright. So we get the pattern for the top, for the numerator. But how does the denominator part work now? Alright. If you say this is 2, the first position, and you have a 2 in the denominator. Suppose you say the position n plus 1. This would be 1 plus 1, which is 2. Okay, good. But when you look at the third position, 3 plus 1, does it work? 3 plus 1 is 4. 2 by 3 is 6 minus 1. Oh, is the new denominator I'm talking about. Third position, we have 3 plus 1. 3 plus 1. No, 3, the third position here, n plus 1. Yeah, 3 plus 1 gives you 4. But this is 6. Oh, so we're going to have to scrap the n plus 1 for the denominator and use something else. So what could it be? Alright, let's review. We saw 1 plus 1 did not work for all of them. Right? Let me redo it. I seem to have made a mistake here. It should be 3. Let's redo that part to clarify. Let me partition this part because what we have out here on the left is the general formula. Now, if we put in the denominator n plus 1 for the first term, 1 plus 1 is 2. It works for the first term. What about the second? The second term, n is 2, not 3, as I said before. It's 2 plus 1 is 3. So it's 3 over 3. But this is 3 over 4. So the n plus 1 does not work for the denominator. So we're going to have to throw that one out and come up with a new formula. The n plus 1 will not work. Alright. What else could we do with the first position 1 and get 2? We could multiply by 2. So let's see. If we multiply the position by 2, call it 2n. In the first position, n is 1. 2 times 1 gives you 2. Okay, it works for the first position. Let's see the second position. In the second position, n is 2. 2 times 2. 2 2s is 4. 3 over 4. Oh, it works so far for the first and second. Let's try the third. 2 times n. 2 times 3 gives you 6. 5 over 6, is that it? 5 sixths. Let's see this one. In the fourth position, it would be 2 by 4. 2 4 is 8. 7 8, is that so? Look up here. Good. So we got the formula. The formula that we're looking for all along is 2n minus 1 divided by 2n. Alright? So it's 2n minus 1 divided by 2n. Alright. You can see that this could also be written as 2n over 2n minus 1 over 2n. And the 2n over 2n here would give you 1. It's 1 minus 1 over 2n. Alright? So that's another way of writing it. But let's just stick to the first that we have. Now, what about B? What could possibly be the pattern and the rule? What could be the rule? We see the pattern here, but what could be the rule that is used to generate these terms? All right, in the first term, we have -2. All right, let's not write the -2 there yet, but we have -2. N is 1, you know. N is 1 in the first term. What could you do to 1 to get -2? If you multiply 1 by 2, you get 2, but a negative. If you multiply 2 by -1, so let's say we have -1 times 2. Good. We have -2. So could it be -1 times n? Let's see. Let's look at the second term. -1 times, let's recap that one. If it is -1 times n, the first term would have been -1. But it's a -2. So we're going to say -2 times n, which is 1. So we have to redo this part and say, suppose we have -2n then. -2 times 1. Remember, in the first position n is 1. Let's write it down so we don't miss it. In the first position n is 1. In the second position n is 2. Third position n is 3. Fourth position n is 4, and so on. Now, -2 by n. -2 by 1 will give you -2. Okay, good. Now, in the second position, -2 by 2 would give you -4. But this is a +4. So this formula is not working. What could we do? Notice in the second position it becomes a positive. Or suppose we say we have -2 raised to the power of n. Now we would have -2 squared for the second, which would be a 4. So we can't do that. So we're going to have to fix it up a bit. What could we do? We have to erase these as well, because that formula did not work. What we need to do is to say, first of all, let's consider what would happen if all of them are positive. That's another strategy you could take. If you say 1 by 2, you get 2. 2 by 2 is 4. 2 by 3 is 6. Alright, guess what? 2 to the power of 1 gives you 2. 2 to the power of 2, and it's 2. 2 to the power of 2 is 4. 2 to the power of 3 gives you 8. Oh, so we see something here. It's 2 to the power of n. So let's say 2 to the power of n. So we have 2 to the power of 1 would give you 2. 2 to the power of 2 gives you 4. 2 to the power of 3 gives you 8. 2 to the power of 4 gives you 16. Alright. So we start to get something now. We have a fifth as well. So let's fill in that one. N is 5 for the fifth term. Now, here, 2 to the power of 5 gives you 32. Alright, we get the numbers, but how do we account for the signs? Let's see. The first one is negative. third one is going to be a negative. The fifth one is negative. So you notice the odd powers are negative. So if we say negative 1 raised to the n, what would that? Negative 1 to the 1 is a negative 1. So when we have the 2 to the n times a negative 1, we get a negative. Now we have the 2 to the n, which is 4, but a negative 1 to the 2 is going to be a positive 1. So the 4 remains positive. Right? So we have negative 1 to the 1, negative 1 squared, negative 1 cubed, negative 1 raised to the 3 will multiply the 8. Negative 1 cubed is a negative. Negative 1 to the 4th will be a positive. So we have a positive 16. Negative 1 to the 5th is negative. So we have negative 32. Now we get it. So what we have is a negative 1 to the n, 2 to the n. So these are what we get for the rules that will follow. So here, the rules that will generate the term. So an is equal to 2 to the n minus 1 over 2 to the n for a. An is equal to negative 1 to the n times 2 to the n for b. Now I got these from our textbook. It might look a bit different, so let's look at our textbook. They say 2 to the n minus 1 over 2 to the n. 2 to the n minus 1 over 2 to the n. Okay, this is exactly the same thing for a. Let's look at what they say for b in the textbook. They say negative 1 to the n by 2 to the n. Negative 1 to the n, 2 to the n. Okay, same thing for both. Alright, so that's how you can come up with what pattern generate the terms, given the terms. When you get the pattern, you know, it's easy to generate terms, but when you get the terms, it's a lot harder to go and struggle and argue to find out what pattern generate these terms. Alright, so those are number sequences. We'll continue in the next video, so I will see you then.